All right, in part two, we're going to talk about methods or functions inside of a constructor function. Okay, let's say we have the same constructor function, but now we're going to add another method. Let's say this.summary is going to be equal to function. And what does this do? Well, let's just have it console.log everything here. This item is, and then we can do this.name. And it is this.condition costing this.price. Okay. So that's what summary does. And then we created a new item called Rolex. Now, if you look at the newly created item on the right here, you see that it created it with the method directly on the object. If we create another object, let's just call this hat, and I'll change this to hat. Console.log Rolex hat. Now you see they both have the same method. If I do hat.summary, okay, it returns this string. Same with Rolex. But do you see what's the problem with this? Well, it has to do with memory management. Constructor functions like this, all of the instances have to have the same method attached to it. And this takes up a lot of memory. Wouldn't it be better if all of the newly created instances do not have this, but when they need it, they can borrow it from their parent or grandparent? And those parent or grandparent objects are what? They're actually just called prototypes. And to see how this works, let me console.log out all of this. Let's say we have const ARR is just equal to an empty array. Okay, we do ARR.length 0. But where did this .length property come from? And how was an array able to use it? Well, arrays are created by the array constructor, right? And all of the methods that we know the array has, like map, filter, and so on, where do newly created arrays borrow those things from? Well, they borrow it from their prototype. If we look at the prototype for array, you can see that this is where all of the methods live. Yeah. Notice that most of the time, all of your mostly used methods do not live on the constructor themselves. They live on the constructor's prototype object. And this is done so that it's more efficient internally for memory management. So you can check if something has a property. If I do array has own property, and let's say map, it's going to be false. But if I do array dot prototype dot has own property map, you see that it's true. Filter, that's also true. Okay, but none of these exist on the literal array themselves. Okay, so we actually don't want our code to do that either. So how can we fix this? Well, for purely constructor functions, you can't use this, okay, because this will always put it inside of the object directly. What you have to do, let me delete this. I'm going to copy this. You're going to have to access the product constructor itself, and then access its prototype, and then add on a method. Let's call this summary. And you can set it equal to that. So now, if you look at our new products, it does not have that method anymore. But if you click on its prototype, you see that now it has the method of summary. But you can still use that. If you do Rolex.summary, it still works, right? Because what it does is that the Rolex object will search its own properties or methods. It's going to search for, hey, is there a method named summary directly on me? No. If there's not, it will go to its prototype, right? When it goes to its prototype, it finds that. And as a reminder, let's focus on this sentence. So when constructors construct new objects, it sets those new objects prototype to its same prototype. And we can actually check this. So our product constructor created Rolex and hat, right? So this constructor's prototype should be the same as Rolex's prototype. And there's many ways we can check that. So first we can do Rolex dot underscore underscore proto underscore is triple equals to what? Product dot prototype. Is this true? True. Okay. We can also do product dot prototype dot is prototype of, let's pass in hat. Okay. And this is also true. We can also do something like an array dot underscore underscore proto. Is that triple to capital array dot prototype? Yes. Okay. And remember, that's how they borrow all of the methods once again. So that's why prototypical inheritance, which is basically what JavaScript revolves around. That's what object-oriented programming revolves around. Borrowing methods on prototypes. Okay. That's it.